Hello and welcome to CAD 201 Parametric Modeling. Today we're in Chapter 6 and we are covering threads and fasteners. These drawings that we're about to do are going to be on page 368 of your text. We'll do one at a time. And so the first one is going to be CAD 201-24, and it's called the base chamber. So we'll come up here to new and make sure that we pick metric. This is a metric drawing. Our last one was probably a metric. Make sure you pick standard millimeter IPT, and then we'll hit create. There's a lot of things that you can do with Inventor, and I'm not even sure that the book covers everything, but we're going to cover a lot. Okay, it's loading. And while it's loading, make sure you're turning to page 368. Make sure that you read Chapter 6. Make sure that you practice with some of the examples through there. If we have time, we'll come back and we will end up doing some other things. And I'll show you how to cut the actual threads out so when you make a 3D model, it's real. Okay, so we'll click on Start a 2D Sketch. We always want to start there. And in this case, I'm going to pick plane XZ. So we'll select that one. I'm going to start with a circle. I'm going to pick in the middle. I'm going to go out, and I'm going to go with the diameter that we have of the base chamber. And looking at it, let's take a look here. Find those dimensions. And it looks like 100. And I don't see the diameter of 100 on the base chamber itself, but when you go all the way up to the cover plate, which matches it, that's where you'll have to look at the dimensions. So we got 100. Okay, so we're doing pretty good. And then we're going to finish that sketch, just like that. And then we're going to extrude. And the height of this, if we take a look at it, it's 65 millimeters. So we'll hit OK. Awesome. Now, next, we'll do a 2D sketch right here, right on the top. We're going to put a circle in here. And how big is that circle going to be? Well, we'll click Dimension, come over here, and go back to the drawing, and we are looking. And it looks and appears to be a diameter of 60. It's right there at the bottom. So we'll go 60 and enter, and then we'll finish that sketch. Now, we're going to extrude that. We're going to pick that one, but this time we're going to pick cut, right? And now, how deep are we going to go? Now, notice that the entire height of it is 65 millimeters, but looking at the bottom, we know that the bottom is 20. 20 from 65 leaves us with 45, and then we hit OK. So we can take a look at this, and OK, it's beginning to look pretty good. Now, the next thing, I'm going to come in with a 2D sketch, and I'm going to pick that bottom surface just like that. There we go. And this time, because we do have a thread, I want you to pick point. Take that point and put it right in the middle, just like that. And then you're going to hit Finish Sketch, right? This time, we're going to come over to the hole command. Now, there are threads here, and let's take a look at this. We're going to take a minute. And so we can do just a regular hole going through there. Now, we can thread it. But when we put a hole in, it could be a drill, it could be a bore, or it could be a ream, okay? A ream is much more specific than a bore. A bore is more specific than a drill, but not as good as a ream. And so depending on what you're using it for, a ream is more costly than the other two. So, be careful. Now, you may also have, as we move down here and take a look, if we were to choose this is a counter bore. If you hover over it, the counter bore comes up. And what that does is you still have the drill going through here or to a depth. But notice here, the counter bore itself is wide enough, the diameter is large enough so that the head of the nut, a hex nut or whatever, it will fit in there, and it's deep enough also so that if there's another part sliding over it, it will not hit that, okay? Now, the next one down is called a spot face. Now, sometimes the spot faces are drilled, they are ground down just enough to have a level surface where the bolt can sit on. And sometimes you'll see a spot face that's in a casting that actually protrudes the surface, and it's there just so that they can machine that down to give a level surface. And then, of course, the last one is called a countersink, and that's for screws, where they have usually an 82-degree angle head, and so that head will go below the surface. But in this case, we're just going to pick the hole. All right. Now, the diameter of the hole, if we take a look at it, the note says M24 by 3. Now, the M tells you that it's metric. The 24 will come over here. That tells us the diameter. Now, notice it changed right here, okay? But there's a pitch. The pitch is 3. Now, what does that mean? That means in one revolution of 360 degrees, when you turn that, the screw will advance 3 millimeters. So that is called the pitch. Okay, so it goes through all. You have your choices, so yes, that's good. You could have also picked 2 or distance if those were relevant there. So also the drill points, if you got a depth, you could pick either the flat or the angled one, depending on the drill bit that you're going to use. And this one's set at 118 by default. Now, coming through here, here's a regular, simple hoe. Next one is a clearance hoe. Now, a clearance hoe, let's say you have a 1/4-20 bolt going through there, okay? That means it's a 1/4 inch diameter or 0.250, and the 20 means that's the pitch. There's 20 threads per inch, which ends up being 0.005. Now, the clearance hoe, if you have a hole like we're going to have on a plate up here, and you want that to clear, it has to be larger than the nominal diameter, okay? And for a 1/4-20, which is 0.250, you would use an H, I believe, or an F drill bit, which is 0.257. It gives it 7/1000ths of an inch clearance so that you can get that bolt through there with no problem, okay? But we're not doing that on this part, but we will be on the next one. Now, this is a tapped hoe, which we're going to come back to, and the last one is a tapered tapped hoe, also known as a pipe thread, okay? So here, we'll click on the tapped hoe. Well, there. Things are a little bit slow today. So that opens up. Now, coming down here, we have ANSI, ISO, all types of standards, but what we're going to be doing will be ANSI. So that stands for the American National Standards Institute. The unified screw threads are English or American, and then we're going to pick metric, which is just about everybody else. Okay, so we got that. We got full depth here. Now, right-handed or left-handed? Almost everything is right-handed, but there are some instances, like on a turnbuckle or a bicycle pedal, where you'll have a left-handed thread. They're not very often, but there are some. Now here, you click here and notice how many threads per inch will or the diameter was 24. Now you can come over here and there's M24 by 0.05, which is really fine thread, to a very coarse thread, which is what we got. Okay, now it's a class 6H by default, and so we will go with that. If you needed to know the minor diameter, it should be in the back of your book or a machinery's handbook. So we will go through here and we'll go okay. Now notice what this did. It put an image in there of what it would look like, but that's all that it is. It's an image. If we really want to cut that out, we'll have to use some descriptive geometry to do that, but we can do it. Okay, looking at this part, that looks good. Now, we're going to come back here to 2D Sketch, go over to 2D Sketch, and we're going to click the top of this surface. Okay, now, notice here, looking back at the book, we have an M8 by 1.25, 17 millimeters deep, and there are 8 holes. So how do we do that? Well, again, what we'll do is we will put a point up here and put a point in there. Okay. Now we're going to dimension it. Now, noticing the dimension, there is a bolt circle in there, and noticing how thick this is. Well, we knew the outside was 100, the inside was 60. So 60 from 100 is 40, but then you got one side and two, so they're 20 each. So if I'm going to dimension from the center here to that point, it's going to be 40. Well, we got pretty close right there. Okay, now we'll finish that sketch. And now we'll go back to the hole command. Wow, here we are already. And so we'll pick hole. Yep. And how deep is it going? Well, we're going to give a distance this time. So the distance that we will go, I believe it told us 17. It is. It's 17 millimeters. Now, still waiting on the diameter to show up. Whoops, didn't want that. Did not want that. That went way too far, too quick. So let's come back and let's put hole in here again. So yeah, the diameter is that. Now looking at the hole, the angle, it's here. It's going to be threaded. Now maybe we have to change it here. It's not a 24. It is an 8. So we'll scroll that till we find the 8. And notice that there is an adjustment there really quick. So M8 by 1.25, and that seems to be the coarsest one that we have there. It's also a 6H, not giving us anything. We're usually accustomed to a class fit of a 1H, 2H, or a 3, but this is what we have here. So that's what we're going to have, and we will hit OK. Now, we have threads there. We're looking. There they are. Okay, now we are going to do a circular pattern, right? We would call this array in AutoCAD. The feature will hover over the feature, which is right here, which selected it, okay? And now the next thing is the rotation axis. Well, if we just pick this hub right here, that finds the center point for us. Well, if you look back at the note, it tells us that there are 8 notes, and they are in 360 degrees, and so we'll hit OK. So we look here, and our part is actually finished for us now. So before we do anything, notice that it is steel. Let's go over here to default, and let's go down to a steel if we can find one. Now steel won't look very good. So there is steel, cast steel, polished. It doesn't really tell us exactly what type. So let's do this. And part of the reason that we do it is when we do the assembly, it will help us to see the parts a little bit better. Okay. So, okay, I'm not real happy with that. So I'll come back here, and computer is very, very slow. And so let's do cast steel. Okay. And let's do, it's hard to find it. Oh, polished steel. Okay, let's do the polished steel. That looks really good. Now we'll come over here to File, and we'll go to Save As. And remember, we got to go to our drawing. So let's go to, I'm going to go to E, and then I'm going to go down to my name. Well, doesn't look like it's there. Maybe it's in C, and then in my name, hopefully. And okay, it's CAD 201, that's good. And so for this drawing, it's going to be CAD 201 dash 24. Now that's the part number, so we'll hit save. Now I'm not worried about making a drawing for this part, but you can go ahead, it'll be a great drawing. Okay, now we're going to come up here to File, and we will save